So they're back, our favorite word problems. So today we're going to focus on those word problems in as extrema. I guess I didn't give you the thing up here. Section 4.4 was extrema again. We talked about the relative maximum, relative minimum. So in this case, we're going to be looking at some word problems and going to apply it back to our economics or our business models that we've been looking at in the past. So I got one example. Shouldn't take too miserable amounts of time to go through this, and we'll see what we've got. So manufacturer of teddy bears finds that the total cost C of X in dollars of manufacturing X bears per day is given by C of X equals 100X plus 200,000. Each bear is sold at a price of P dollars, and P is related to the demand equation P equals 400 minus 200th X. If all bears that are manufactured can be sold, find the daily level of production that will yield the maximum. So we want the maximum profit. So in order to find the maximum profit, we first got to find our profit function. Well, let's recall what we know about the profit function. The profit function is equal to the revenue function minus the cost function. So I first need to find my revenue function. Again, we must recall what the revenue function is. The revenue function comes from the demand function, and that's going to be the price. And we're going to multiply it by the number of units that we sell. So it's going to be, remember, X times P. So we're going to take X times that price, which is 400 minus 200th X. Or, simplified out, we get 400X minus 200th X squared. So my profit function is going to be that 400x minus 200th x squared minus the cost function, which is 100x plus 200,000. And go and clean this up. So I get 400x minus 100 gives me 300x. I guess I should have put my decimal in there, or my x squared there first. That's okay. Then minus my 200,000. Be careful, make sure you multiply that negative through before you go and combine like terms or add things on. So that gives me my profit function. My maximum is going to occur, or my extreme is going to occur when I find P prime. So my derivative, I'm going to put this in order now, derivative of 200th x squared is going to be negative 400th x, and then plus 300, derivative of 300x is 300, derivative of 200,000 is 0. So we're going to look at this. We're going to set this equal to 0. If we set that equal to 0, I can go ahead and solve that. I'm going to take my 300 and divide it by my 400ths. And I end up with a value of x equals 7,500. So what does that mean? That means that we have 7,500 units, because x is talking about the number of bears per day. So we're going to produce 7,500 bears. Well, is this a maximum? Is this a minimum? Generally, with all of these problems, the number that we get out is going to be our answer. But we do want to check this. So how can we check that this is a maximum? Recall, in order for us to have a maximum, we have to have a function that is increasing and then turns decreasing. So at that point, we have to show that we have a positive slope to the left of it and a negative slope to the right. So what I can do is go back to my first derivative test. I can look at negative infinity. Actually, in this case, we don't need to go negative infinity, do we? We can go 0, because we can't produce anything less than 0 bears, up to 7,500, and then 7,500 to infinity. And we can go ahead and find a test value, just like we did when we graphed and we created those interval charts. So I'm going to say 8,000. Oh, sorry, we need to be below that. So 7,000, and then above 7,500, I'm going to say 8,000. I can go back to my first derivative. If I take 400ths, negative 400ths, and I multiply it by my 7,000, I'm going to say I get a negative 280. So I know that that's going to be a positive value when I go to my first derivative. If I plug in 8,000 times my 400ths is going to be a negative 320. Negative 320 plus 300, that's going to be a negative value. So I go from a positive to negative, or increasing to a decreasing. So this tells me that I do have that absolute maximum. So in order to maximize profit, and we can write that out if we want, to maximize profit, then we produce 7,500 bears per day. And that would be our answer. So that gives you an idea of kind of what the problems that we're going to be looking at are today. You're going to have to figure out what your equation is to start with, and then you're going to maximize or minimize. Generally, we maximize profit, maximize revenue, and we want to minimize our cost. So if you have questions, please let me know. Good luck, enjoy, and enjoy those word problems.